Special care has to be taken when the pipe between pumping station and sewer has several high points. The high and low points must be known in detail and a calculation is necessary. Regarding the resulting static head, regarding siphoning, vacuum and probably necessary air release and ventilation, regarding local velocities to press out trapped-in air cushions. Here several scenarios are possible. In such cases, the calculation by a specialist with knowledge and experience is mandatory. In this short animation, we will show the behaviour of water and air in the pipework by three typical examples. In our first example, we have all high and low points within a band covered by barometric head and vapour pressure. Mostly, meaning up to an elevation of about 900 metres above sea level, we assume this band to a width of 9 metres. Additionally, the discharge is higher than the highest high point. No special measures have to be taken against vacuum effects, and the static head calculates straight from the discharge of the level in the pump sump to the outlet of the pipe. The friction losses have to be calculated for the full length of the pipe. In case the difference between maximum high and minimum low point is not covered by barometric pressure, meaning in most cases bigger than 9 metres, special calculations and measures are needed. Also critical aspects are pipes with long downward parts. As the number of possible scenarios is endless and trapped air cushions may lead to a complete malfunction of the installation, the analysis by Sulzer specialists is mandatory. In this example, the discharge is below the maximum high point. This means that the pipe will never be filled completely, as the ventilation valve will always part fill with air. There is no constant duty point for the pump. The static head is changing from pump start to pump start, and also the frictional losses will change, as the pipe is only part filled. Special care has to be taken regarding velocities to press air cushions along a low point. In case the next high point is at relative high against its low point, the air cushion may be compressed when the pump is operating. This can mean that the velocity at the side of the cushion pointing against the low point is lower than the velocity at the side coming from the ventilation. There may be lots of highs and low points when the pump is following the topography in a hilly area. As last example of this animation, we will show a pipe with two ventilated high points. The more high points, the more intensive the calculation is getting. The pipe will never be completely filled, as the ventilation valves will always part fill with air. The duty point of the pump may vary in a wide range. All these calculations must lead to the correct choice of the pump model. Special care has to be taken regarding velocities to press air cushions along a low point. Pressing the air cushions through a low point of the pipe needs a certain minimum velocity. A special problem arises when the air cushions are compressed due to high static head after a low point, and when, as a consequence of the velocity at the end of the air cushion is lower than it is at the beginning. Please bear in mind that this is a matter for our specialists.